Now let's look at collision resolution strategies, and let's start with chaining. The idea of chaining is that instead of storing elements in the hash buckets themselves, these hash buckets kind of point to a list, right? List of elements, not just one element. Now, whenever we have a collision, we can insert the new element in the list. So let's get back to our hash function that we've been using as an example, h of x equal x mod 10. And let's do a sequence of insertions to see how that works. So let's insert. Let's start with 13. In order to insert 13, we need to compute h of 13. That is 13 mod 10, which is 3. So we hit bucket number 3, and now we insert the element in the list at bucket 3. So that is 13. Let's try 33. H of 33 is 33 mod 10, which is again 3. Now there's a collision, but that's not an issue. We can add the element either at the beginning of the list or at the end of the list. So let's add 33 here. Let's say we want to insert 20, right? So 20 mod 10, that is 0. So we go to bucket number 0 and we insert 20 in the list maintained at bucket number 0. Now let's see how search works with this scheme. So let's say we want to search for 33. So again, we need to compute h of 33. That is 3. We've just computed here. So we hit bucket number 3. And now we need to scan the list looking for 33. So we look element by element. It's here. So we declare it found. Let's say we want to search for 20. So again, we compute h of 20. That is 20 mod 10, which is 0. So we hit bucket number 0, search for 20 in this list. It exists, so we declare it found. Let's look for 53. H of 53 is basically 53 mod 10, which is 3. So we hit bucket number 3. Now we again scan the entire list looking for 53. Once we hit the end of the list, we know that the element doesn't exist, so we declare it not found. So in terms of performance of these operations, insertion basically takes an order of constant because, you know, if we're inserting at the beginning, that's order of constant. And if we're maintaining a tail, inserting at the end is also order of constant. However, in terms of search, in the worst case, it could happen that all the elements end up in the same list, right? And then if we want to search for a particular element, we need to scan this list element by element looking for the key that we're having. And that's going to be in order of n in the worst case. However, as we will talk later, with proper sizing of the hash table and proper hash function that we're using, we hope that this worst case doesn't happen quite often. On the average, is going to remain constant.